Alright, so 103, trig rules. So there are actually 6 trig rules for derivatives, and there's 2 main ones. Everything else follows from that. So the 2 main trig rules are the derivative of sine is cosine, and the derivative of cosine is negative sine. Okay, so those are the big ones, and they're pretty easy to remember, right? There's a little bit more to it, but let's go to the other 4, okay? So we have sine, cosine, tangent, cotangent, secant, cosecant, right? So let me show you how these 2 help us get the other ones. So let's say you are trying to find the derivative of tangent. So if you're trying to find the derivative of tangent of x, just x, then what you're going to do is you're going to change that tangent to a sine over cosine. Well, what do you do when you have a fraction and you want to take a derivative? A fraction would be a quotient. So it's low d high less high d low, denominator squared below. So then I go ahead and do that. So low d high less high derivative of the low, and then denominator squared below. And then I kind of clean that up, right? So isn't that cosine squared plus sine squared? What's cosine squared x plus sine squared x? It's 1. So 1 over cosine squared, do I have a little bit further? Yes, is a secant squared x. So that's where tangent derivative comes from. It actually comes from sine and cosine. So what you're going to do is you're going to find the derivative. See, so it says they do. So you're going to finish the derivative of cotangent. So you're going to try to find it. Go ahead and do it on your notes, and then you will find the answer on the homework help link for today, and also you'll see the answer below, okay? And then let me show you one more. So the other one I want to show you is secant. So how would you get the derivative of secant? Okay, let me move this, and then I'm going to just show you the whole thing, and then we'll go over it, okay? So the derivative of secant is going to be another 1 over cosine. So 1 over cosine is a quotient. So low d high, the derivative of 1 is 0, less high d low, denominator squared below. And then if I go ahead and multiply everything out, I get a positive sign on top, I get a cosine on the bottom. Sine over cosine, isn't that tangent? And then 1 over cosine, isn't that secant? So that's how you would get secant x tangent x. Okay, so you guys are going to find the derivative of cosecant. Obviously it starts with that. So find the derivative of cosecant x and see what you get. And then check on homework help line, okay? So actually, here are all 6 derivatives for your trig functions. So it looks like a lot more, but basically to find the derivative of sine of anything, you just do cosine of that quantity, and then you can't forget, usually on the other notes I wrote box prime. This means the same thing. Don't forget to take the derivative of the inside. So go ahead and jot down all 6, so pause and then jot down all 6 derivatives. These are the actual derivative rules, okay? So make sure that you have the negatives for your cotangent and cosine and cosecant. Make sure that you have your squares in the right place, all that good stuff, okay? So derivative of sine, cosine, tangent, cotangent, secant, and cosecant. Okay, so let me show you some examples of each one, all right? So find the derivative of the following. Okay, so let's say you're trying to find the derivative of, can I move this? Yes, I can move. Sorry. So find the derivative of y equals sine of x plus cosine squared x. So the first thing I would actually do is I would change this into a cosine x quantity squared, because really that's what this is. And when you change it to this, you realize this is not first and foremost a trig derivative. This is first and foremost a power rule because it's a quantity squared. So this isn't actually cosine of box. This is a quantity squared. Okay, so to get the derivative of sine, so right here it says derivative of sine is cosine quantity times the derivative of the quantity. So I would have cosine 3x times what? So it would be times 3, right? The derivative of 3x is 3. And then what's the derivative of this? Actually, it's a power rule. The 2 comes forward, and then you have cosine x to the first power because it's a quantity to the first power. And then you take the derivative of the quantity, which is a negative sine x. So this is the second piece. And then just to clean it up a little bit, there's not much more we can do with it, is going to be something like this. And then if you go do I go one more step? Yes, you can go one more step because here's what I recognize. And I understand if you don't, but it's been a while, because it's been a while, but you should. So 2 cosine x sine x, that is a double angle formula. So really we can rewrite that as sine of 2x, right? Isn't that the double angle for sine? So that's why I have a happy face. So this is the final answer for A. Okay, we're going to try another. So let's see. For B. So let's say you have something like this. Y equals -5 cosine of 2x. So you can do this a couple different ways, but some people, they like to see the -5 as a quantity, and then they like to see this cosine as a quantity. If you see this as a quantity and this as a quantity, then what you can do is the product rule, right? So it's this times the derivative of this plus this times the derivative of this. So if we write it out that way, what we realize is that, so I have my -5, I have my derivative of cosine, which is a negative sign, and then times box prime, which is the derivative of this, which is 2, plus, and then that times the derivative of -5, that is 0. The derivative of a number, a constant, is always 0, right? So if you work it out as a product rule, you're going to get the right answer. The final answer, if I clean up this first term, is just going to be 10 sine 2x. I didn't write it neatly enough. But you can also just realize that when you have a constant in front of anything, that you don't actually have to use the product rule. Because what happens is, when you have a constant, you just leave it. So -5, and then you take the derivative of this, which is like that, and then you clean it up and you get that. Because whenever you do the product rule with this, and you try to do the derivative of the constant, it always gives you 0 anyway. So that second term is going to go away anyway, okay? So just realizing that any number in front, you can just leave it. So let's say you're going to do something like this. So it's just a y equals 4, the sine cubed x. That's a little messy. My 3's not big enough. So it says sine cubed x. So the first thing I actually want to do is, this is not a sine, first and foremost. This is a power rule, right? So it's a quantity cubed. Okay, I'll try to be more careful about my powers. All right, so then how do you take the derivative of 4 times this? Well, there's a 4, which is just a constant, so I can leave it. And then I take the derivative of this piece over here, which is a power rule. So the 3 comes forward, quantity squared, times box prime, which is the derivative of sine. So that is all of my second step. And then I just wanted to show, if I treat this like a product, see how that's a 0 again? So really, I can just deal with that. So here's my 4, here's my 3 forward, okay? And then I clean that up a little bit. And then if I were to, so this is fine, but I might realize that this right here is sine x times sine x. So there's a sine x, and then there's another sine x. which means I can use my double angle formula for one of the sine x's. So if I go like that, there we go. Put the 2 in front. Yeah. This is a double angle formula. So if I take out a 2 and a sine cosine, I get this. Right? I get a sine 2x. And then what's left is a 6 and then an extra sign. Okay? So this, again, using my double angle formula. Okay. So for D, you should give this a try. So y equals secant of a quantity. So for this one, look at the formula. What is the derivative of secant? So write out that first step and then check it. Do it for real. Okay. And then you get this. So secant quantity, tangent quantity, times the derivative of the quantity. Normally you put this, if it's multiplying everything, you put it in front. And then that's it. So there's not much to do with that. Okay. And then last two, but I'm only going to show you one of them. So E. Let's say you have y equals the quantity 3x squared plus 1 times the quantity sine squared x. Again, I'm going to right away change this to sine x quantity squared. Okay? So this is obviously a product rule. So I used my orange to show one thing, like my box, and then my green would be like my triangle. Okay? So using the product rule, I just go through it slowly. And then here's my box, here's my derivative of the triangle, here's my triangle, here's my derivative of the box, okay? And then I clean it up a little bit. So if I clean it up a little bit, I multiply out. See how there's a plus here? 3 times 2 is 6. X squared, here's my x squared. And then sine x cosine x. And then there's a plus. And then so it's 2 sine x cosine x times 1. So I just write all that out. Okay, so here's this quantity times this. All over there. There's a plus, there's a plus. And then plus, and then here's my 6x just in front of my sine squared x. Okay, cleaning it up a little bit more. There's actually 2 ways to write this final answer, so I'll show you one way. Okay, neither of them are more right or more wrong. So one way is just going to be like this. So all I did, I have 3 terms. I can see the plus and the plus. I factored out everything I could. I see there's a 2 that I can factor out the front. There's also a sine x that everything has. So I factored out a sine x. What's left here would be a 3, an x squared, and a cosine. What's left here if I factor out the 2 sine x is cosine. And then what's left here if I factor out a 2 and a sine x is going to be a 3, an x, and then another sine x. Okay? This is the final answer. That is totally fine. But from here, I'm going to show you another answer. So we can also instead, I'm going to make it a little smaller so you can see all of it. Instead, I can recognize this and this both have double angle formulas. So this one's real easy to spot. This is a sine 2x. There's my sine 2x. Here's my last term. I just leave it alone. This is my second term, sine 2x. This one, again, I have a sine x cosine x. There is a 2 in front. If I factor that out, I get a 3 left, and then I have my x squared, and then again I have my sine 2x. This is a perfectly acceptable answer. This is also a perfectly acceptable answer. Just be careful because if it's multiple choice, I'm not going to give you both. Don't worry. I'm not going to try to trick you. But you will have to, like, if I only give this answer, you'll have to choose that one. If I only give this one, you'll have to choose that one. So just be able to, like, kind of go back and forth a little bit and find all your options. Okay. So the last thing you're going to check and or put on homework helpline is F. So notice the difference between this one and this one, right? So how would that be different when you do the product rule? How would this be different than this when you take the derivative of sine squared x versus sine x squared? Okay, so you're going to finish F, and then you're going to check that homework helpline to see if you did it right And the answer, I will tell you the answer. Can I show it? I can show it. I'll tell you the answer, but you got to show all your work on homework helpline is this. All right, good luck. I will see you soon.